So today's the topic that we'll be doing is differentiation. We'll understand the concept of differentiation, notations that we will use for differentiation, and how to differentiate. So there are 3 points that we need to focus on. Okay, what is basically differentiation? What do we write when we are showing differentiation? And how do we differentiate basic algebraic functions? Right? Okay, let's take the example of a curve. If I draw a curve for you, what can you tell me about its gradient? The gradient is the gradient constant for the entire curve? Is the slope the same? Imagine you have an object, if you have placed it over here, and if you have placed it over here, will it experience the same slope? So that means the slope or the gradient is not constant. Is this clear? Okay, but what if I take just a part of the curve and I zoom it in? Will it appear to be a straight line? Imagine it's the earth. If you go from even from one city to the other, do you feel the curvature of the earth even though the entire world is curved? No. So that means curves are made up of small infinite lines. So if I take a very small piece of that line and of that curve and I zoom it in, I will get a straight line. Is that right? Okay, now understand one thing. I want to make a gradient function for this curve. Say, and I want to deal in variables because the gradient is different at every point. I cannot say a change in y itna hai or change in x itna hai. I cannot say that. So I will use variables for that. कि change in y को ये कह दिया और change in x को ये कह दिया, ठीक है? So the change in x is called dx. The change in x is called dx, and that is a variable change in x. And the change in y is called dy. That is a variable change in y. That change can vary from every point to point. Make sense? Is this clear? Okay. So now, if I just simplify this, I'll say, okay, at this point, the value of, let me change the color for this one. Okay, now I'll say at this point, the value of x is x. And at this point, the value of x is x plus h. Again. So what will be the value of y if I'm specifically using function notation right now? This will be fx over here. Is that right? Any function of x. Right now I'm not even specifying the function. Okay? And here the value of y will be f of x plus h. So how do you find dy by dx or change in y upon change in x for this one? y2 minus y1 upon x2 minus x1. So if I tell you that I need to differentiate this, you can say that dy by dx can be found. The value of y2 is f of x plus h. The y value of y1 is fx. It can be any function. And the value of x2 is x plus h minus x. Or in place of x2 minus x1, I can simply write h as well. What is the change in x? H hai. X and x cancelled out. I'm left with h. Is that clear? This is called the first principle. What is this called? F of x plus h minus fx upon h. That is called the first principle. Is this clear? It can be for any function, and h is so small that it is almost approaching 0. Remember we did it in even sum to infinity for geometric progression. The values are so small that they don't need to be counted in the entire thing. Is this right? So here h is so small, individually h might have a value, but when I take it with other values, I will not eventually need to add it. It is so small that it is almost approaching zero. Does this make sense? No one will ask you the first principle in A levels. Let's be sure. It's just one-time conceptual development. Okay. Okay. Now let's take an example. For example, I take the very basic quadratic function x square. How will I differentiate it? Understand the dy is the variable change in y and dx is variable change in x. So fx is x square, right? Using the first principle, this will become x plus h whole square minus x square upon x plus h minus x. Yes, you are right. H ही रह जाएगा. मैं जानबूझ के लिख रहा हूँ so that you can relate it to y2 minus y1 upon x2 minus x1. That is the only reason I am writing it down. You are right. We will eventually be left with h. हाँ हाँ हमेशा हमेशा नीचे h ही रहेगा. You are absolutely right. नीचे हमेशा h ही रहेगा. And again, h is so small that it is almost approaching zero. So I'm left with h. If I expand this, I get x square plus 2xh plus h square minus x square. Simplify करूँगा, I get 2xh plus h square upon h, and then I get cancel out. I'm left with 2x plus h. Makes sense? h अलग अलग लिया 2xh upon h and h square upon h. So this is what I'm left with. Makes sense? What is this? This is called the gradient function. Why it does not provide me with a gradient? Because gradient is not constant. कि y2 minus y1 करके एक variable nature में मेरे पास आ गया कि I'll just plug in the value of x and I'll get my gradient. But one thing is there, sir, h कैसे निकालेंगे? Again, h is so small that it is almost approaching. अगर आपको ये वैल्यू किसी में ऐड करनी है, very small value, so small that it is approaching zero. So if will adding that value change that function? Change the value, sorry? Nahi. So it is so small that it is almost approaching zero. So can I negate it at this point now? Can I say the derivative or the differential is 2x? बिल्कुल, लेकिन अगेन इतना छोटा है. सही है. एंड हमने h को पॉजिटिव ही कंसीडर किया. हम कहते हैं इतना छोटा है दैट इट इज ऑलमोस्ट अप्रोचिंग जीरो. This is called the first principle. And we have just used the first principle with the example of x square, which is a very basic quadratic function. Is this clear? Okay. This is just a one-time conceptual development. I'm telling you, A levels will not question you on the first principle, but it is, I believe, in even the syllabus says it is necessary to understand differentiation, because that is important even for AS and for A2. We have just taken this example of x square and we saw that once we differentiated, it became. Do you see a pattern in this? The function was x square and after differentiating, it became 2x. What is the pattern that you observe? Power 2 थी, वो 2 power की बजाय यहाँ आके the 2 multiplies. And power जो 2 थी वो eventually क्या बची? 1. So you can make a pattern for algebraic differentiation with this. that if you have a function y, which is ax to the power n, and we call this, if we are trying to differentiate the entire y with respect to x, we have developed a pattern. Power यहाँ है तो power यहाँ के multiply हो जाएगी, and whatever the power is, it will reduce by 1. 2 से 1 हो गई थी ना, पावर 1 कम हो गई थी, the power reduces by 1. एक पैटर्न डेवलप कर लिया, उसके पीछे the logic is still the first principle. Is this clear? If I were to differentiate this, now understand, I'll say that these are two different functions. 3x एक अलग function and plus 8. If I were to differentiate it, मैं हर किसी को individually differentiate करूँगा. So if they are adding or subtracting, functions are adding or subtracting, you will differentiate each one of them individually. So if I tell you to differentiate this, first of all, how will this look like? ये क्या नजर आना चाहिए? If you draw it on a graph, this will look like a straight line, and the gradient of that straight line will be 3. So अगर differentiate करने से हमें 3 मिलता है, that means we are doing everything right. सही है? Okay, so how do I differentiate 3x now? Now we will not go to the first principle again and again. We will use the pattern. 1 इधर multiply हो गया, 3 हो गया, 0 हो गया, so no x. यहाँ पे there is no x over here. That means x is a power. If there is no x written, so x has a power 0, and when you multiply that 0 with this, तो 0 ही हो गया ना पूरा. So if you are differentiating a constant, उसका derivative 0 होता है. ठीक हो गया? You got the derivative or differential as 3. अब यकीन हो गया कि gradient is 3. Is this clear? Similarly, if you are differentiating x squared, the derivative or the gradient is 2x. If you are differentiating fx, अगर मैं ये notation use करूँ, पहले understand how will we write it? I'll say I need to differentiate the entire fx with respect to x, and that can also be written as f dash x. अगर आप fx की notation को differentiate कर रहे हैं, so the right way of writing it down is f dash x. And how will you differentiate it? क्या होगा? 3x power 4 का derivative क्या होगा? 12x cube. Is this clear or not? So now you'll call it f dash x, and that will be 12x cube. अच्छा, अगर मैं कहूँ सिर्फ इसको differentiate करो 2x cube को, तो अब आप कहेंगे I have not named it y, तो आप इसको y नहीं कह सकते. You just say this is how you write it, that the derivative of 2x cube with respect to x is 6x square. So understand the notations. Did you understand the notation? You must know कि हम क्या लिख रहे हैं. You must know the concept as well. Is this clear? And you must know how do we differentiate. So, and we are just using this pattern, and we understand when functions are adding, so we differentiate each one of them individually. Is this clear?